right, so today's lesson is lesson 1.3. We're going to be looking at data. We're going to be looking at lines of fit, lines of best fit, coming up with equations to represent the data. We're also going to be using our graphing calculators quite a bit, so make sure you have those next to you. If you don't, pause, go run and grab your graphing calculator and then come back, okay? All right, so the first thing I want to do is actually talk about the graphing calculator. I'm often going to ask you to clear your graphing calculator, or if you're doing some calculations and you think something is wrong with your calculator, I would suggest just restarting it. That kind of like clears it, gets it back to its normal functions in case something weird with settings is going on for you. So a few different ways to clear your graphing calculator. If you have one of the newer, like thinner versions of the graphing calculator, on the back there's a teeny little restart button. You can use like a pin or the tip of your pencil or pen and just hold it in, push it in and hold it, and then you'll see a message that says cleared or RAM cleared, okay? So that's one option. The other option, and everyone can use the second option, is you hit second plus 712, and I'll show you so you understand what I'm talking about. So you hit the second button, then the plus, and then 7, because if you scroll down to number 7, it says reset, but you don't have to scroll down. You can just hit 7. All right, so 7. And then 1, because all RAM, or you can just, it's already highlighted, so you can push enter, but you can just push 1. And then 2, because number 2 says reset. So you can scroll down and hit number 2, or just hit the 2 and it will do it for you. And then it says RAM cleared. Okay, so now our calculators are cleared. There's going to be other things I'm showing you with the calculators throughout the lesson today and tomorrow. So just make sure you have them nearby. Okay? All right, so that's how, excuse me, you clear your calculator. Next, we have some vocabulary. So first is line of fit. Now, these are probably not new terms, line of fit, line of best fit. You guys use these terms like probably even in 7th and 8th grade when you're working with data and scatter plots, okay? But line of fit. When the data in a scatter plot show an approximately linear relationship, you can model the data with a line of fit. Line of best fit is the line that lies as close as possible to all the data points. And we're going to use the linear regression feature on the calculator. Okay, that can be used to find the line of best fit. Correlation coefficient, denoted by an R. So when we are using our calculator, you'll see R equals, okay? And it's going to be a number between -1 and 1. And that measures how well a line of fit sits with the data, okay? When R is near -1, so if you have like -0.9876, whatever, that means that the line lies very close to all of the data and the line has a negative slope. If the R value is close to 1, so if it's like a positive 0.897 or something like that, that means that the line is a good line of fit. It sits very close to all the data points and your slope is positive. All right, if R is closer to 0, so if you get some value of like 0.2 or 0.0076 or something that's not really close to 1 or -1, that means that the points do not lie very close to the line. Okay, the points are like scattered all over and the line is not really fitting the data very well. Okay, now to get the correlation coefficient, to get that R to show up on the calculator, and I'll go through this with you when we need to do it as well, but I'll show you here as well. Hold on one second, let me just darken my calculator. Okay, so what you're going to do is push second 0, then scroll down to diagnostic on and push enter 2 times, okay? So second 0, it takes you to the catalog. If you see above the 0 button in blue, it says catalog. I'm trying to get the glare off there. So second 0 takes you to the catalog. If you're ever looking for something on your calculator, some kind of function, you can't find where it's hidden, this is a good place to come because it's in alphabetical order. Now you can hit the D, the alphabet key, and it'll take you down to the D's, or you can just kind of scroll down. I'll just scroll down for a second until you get to the D's. Doesn't take all that long. And you're looking for something that says diagnostic on. Oh, am I there? Yeah, diagnostic on. Once you're there, you're going to push enter. All right, it says diagnostic on, but you have to push enter a second time until it says done. All right, now that's going to give you the R value. If you forget to do this, the R value won't show up when we go and use our linear regression feature, and I'll remind you of that when we do our first problem, okay? So give me a second. I have a little bit more information I want to give you guys before we jump into our first problem. But let me erase the board. All right. So just some quick review from Algebra 1 that we'll be using. If we're writing a line in slope-intercept form, so line in slope-intercept form, it's y equals mx plus b. Remember, m is your slope, b is your y-intercept. Okay? If we want to write a line in point slope form, it's y minus y1 equals m times the quantity x minus x1. And if we're trying to calculate the slope of 2 points, it's the change in y over the change in x. Rise over run. Okay? So those are all important things to remember from Algebra 1 that we'll be using in the lesson today. Okay? So let me erase again. All right, the first problem we're going to look at, it's actually a graph. And it's a graph showing cell phone costs. This is your first example. Cell phone costs. Costs with an S. Okay. And we have our y-axis and our x-axis. And your y-axis is cost in dollars. Cost in dollars. And your x-axis is number of text messages sent. Number of text messages sent. Okay. Now there's a break in the scale. So the break in the scale means that you start at 0, but then it jumps all the way up to 48. But then it's not going to continue to jump by 48. Then it goes, let's see, 50, 52, 4, and that's good. Now there's not really a break in scale for the x-axis, but it jumps by 5s each time. So it's 5, 10, 20, 30, 40, 50. Okay. And there's a plot pointed at 0, 50. And then there's a point plotted at 10, 51. And then it goes up like that. Okay. So the directions here say, use the graph to write an equation of the line and interpret the slope. So we want to write an equation of this line and interpret the slope. Okay, explain what the slope represents. So in order to write an equation of a line, we need 2 pieces of information. You need to know what is the slope, the m value, and what is the y-intercept. That's your b value. Those are the 2 key pieces of information you need to know. Okay, so your slope, rise over run. Now you can just kind of count, or you can put the coordinates into the slope formula. It's kind of up to you. All right, let's do the coordinates. So the change in y, you're going, let me write the coordinates down, sorry. This is 1051, and this is 050. Yeah. All right, so change in y, we're doing 51 minus 50 over change in x, 10 minus 0. So we have 1 over 10. Okay, there's your slope, which we'll interpret in a moment. Now your y-intercept, where does the line cross the y-axis? It crosses it at 50. We don't even have to do any calculations. We can just look. So your equation, y equals mx plus b, y equals 1/10 x plus 50. Okay? So when you're asked to write an equation, that could be your equation. Now, since we're dealing with money, you might want to calculate this or turn this into a decimal. 1/10 is, it just might make more sense in terms of the problem. But either one of these equations would be perfectly fine for your answer. All right, so what does the slope represent? Okay, what is 1/10 or 1/10 representing? Okay, so think about it before I just give you the answer. Think about it in terms of this problem. It's talking about cell phone costs going up in cost, going over a number of text messages. So what does it represent? A few different ways of stating it. I'm going to look at this number and I'm going to say it's 10 cents per text message. It's 10 cents per text. Okay? That's one way of thinking about it. All right? If you think about the rise and the run, you're rising $1, running 10 text messages. So you say for every $1, you get to send 10 text messages. It's the same basic, answer, but just in different terms. Okay. All right. So that is how you would work on a problem like that. Let me erase and we'll try something different. That was my toe. Okay. Now this is kind of a longer word problem, so I'll read it to you, but then I'll just write the most important information. So it says the cost of parking in a parking garage in Chicago is represented by the equation y equals 15x plus 20. Okay, so I'm going to kind of write that down. We'll start with, this is our example. We're going to say Chicago. And this is parking. The cost to park in the Chicago parking lot is y equals 15x plus 20. Okay. Where y is the total cost in dollars and x is the time in hours. Okay. The table shows the total cost to park in a parking garage in Denver. And I have to give you that table. So then I'm going to say, put it over here, Denver parking. So they don't have an equation, but they have this table. Remember, y is total cost and x is hours. So hours, x, cost, y. So for 2 hours, it costs $45. For 3 hours, it costs $51. For 4 hours, it costs $59. And for 5 hours, it costs $67. Okay. 59. Okay. Which city's parking garage charges more per hour and by how much? After how many hours would parking in both cities cost the same? Okay, so we have like 3 questions. It says, which city's parking garage charges more per hour? So, which charges more per hour? That's one question we need to answer. Then it says, after how many hours, and by how much, sorry. And by how much. And then, after how many hours would parking in both cities cost the same? After how many hours is Chicago equal to Denver? All right, so we kind of have a lot to think about here. Now, when you look at Chicago, it's already given in slope-intercept form. Y equals 15x plus 20, okay? So that's telling you to park in Chicago's parking lot. There's a flat rate, because even if wouldn't make sense that you would park 0 hours, but I guess, you know, if you're just driving in and driving right out, they're going to charge you $20, okay? And then after 1 hour, it's going to be the $20 plus the 15. And then for 2 hours, so 2 times 15 is 30, it's a $20 plus 30. 3 hours, right? So you have this flat fee of 20 and then $15 per hour. So let's write that down. Flat fee, $20, and then it's per hour, 15. So if you think in terms of y equals mx plus b, the m is the per hour rate and the b is the flat cost. So we probably want to take Denver's information, which is in table form, and get it into an equation slope-intercept form so we can figure out the same. Okay, and there's a few different ways to go about this. You could find the rate of change, right? You could find what are we increasing or decreasing, and then since it's 2 hours, 3 hours, 4 hours, 5 hours, kind of work backwards and figure out for 1 hour what is the cost. That's one option. You could also plug into slope formula, so that's what I'm going to do. Pick any 2 points, it doesn't matter which, and you're going to find the change in y. So I'm going to do 51 minus 45 over the change in x, 3 minus 2. All right, and you're going to get 8 over 1. Okay, so it's $8 for this, or 8 is the slope. Okay, and then you need to write the equation. Now, since they gave the equation in slope-intercept form, I want my final answer to be slope-intercept form, but since I'm given a bunch of points, I'm going to start in point-slope form. So that's y minus y1 equals m times the quantity x minus x1. This is a good form to work in if you know the slope and you know one point that you can use, and you have 4 different points you can choose from. So you're going to pick a point and plug it in for the x1, y1. It looks like I just chose the first point. So, and I put the wrong number in, I'm just noticing now. Oh, this is wrong. I'm sorry, guys. Change that. It's a 43, not a 45. Just notice my, yeah, double checking everything else. Yeah, everything else is right. So it's going to be y minus 43 equals m times the quantity x minus 2. Now m, I actually know. I should have put that in. M is 8. So I'm going to erase the m, put the 8 in. Okay, so now you can distribute the 8 into the parentheses. Y minus 43 equals 8x minus 16. I'm going to add the 43 to both sides. All right, so now I have y is equal to 8x plus 27. So now that I have slope-intercept form, just like I had up here, I know that my flat rate is $27. Flat fee that they charge, $27. So I guess if you only park for like 1 minute and then decide to leave, they're going to charge you $27. But if you park for an hour, right, X is hours, 1 times 8, $8 for the hour plus the flat rate. All right, so the per hour cost is $8. So now we can probably answer some of the questions. It says, which charges more per hour and by how much? So per hour, $15, per hour, $8. So obviously Chicago charges more per hour. And by how much does it charge? $7 more an hour. So the answer here would be Chicago charges $7 more per hour. All right, the last thing says, after how many hours is Chicago equal to Denver? And I wrote it this way on purpose. When is Chicago equal to Denver? Well, if this is Chicago's equation that they use to figure out their rate, I want to know when is that going to be equal to this? So I take Chicago, which is 15x plus 20, and I set it equal to Denver, which is 8x plus 27. And I can solve for x. All right, so let's subtract 20 from both sides. So I have 15x equals 8x plus 7. Now I'm going to subtract 8 from both sides. So I'm going to have 7x equals 7. X equals 1. So that means 1 hour of parking costs the same. I'll just say 1 hour. Okay. And that is it for that one. All right, I think I just have one more problem I wanted to show you. So hold on while I erase the board and get it set up. Okay, so I'm going to show you on the calculator how to put data in and look at a scatter plot and then come up with the line of best fit. And we'll do more of this. I'm making another video for a second day, so we'll do more of this with the calculator, but I want to show you at least one problem before we go today. All right, so the directions are going to say use linear regression on calculator to find equation of the line of best fit and interpret correlation coefficient. Okay, so a scatter plot is given. Let me just quickly sketch it. X, this is Y. All right, so the scatter plot is given. One point is, let me just do my scale. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the first point that is given, you can plot it as well as 1, 5. And it's going to be helpful to actually write the coordinate next to the point because you're going to have to put them in your calculator in a second. The next point is 2, 2. Then I have 3, 1. Then I have 5, 2. Then I have 5, 5. And that's it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Good. Okay, so the first thing you want to do is you want to create a scatter plot in or on, your calculator, and I'll talk you through the steps. So you're going to want to push the stat button right here, S-T-A-T, and you want to edit. So edit's already highlighted, just push enter. Okay, and you have these lists, L1, L2, L3. You're going to enter the X coordinates in L1 and the Y coordinates in L2. So the X coordinates are 1, 2, 3, 5, 5. So I'm going to enter that in. 1, 2, 3, 5, 5. Just push enter after each one. Then use your arrow to go over to L2. Now put in the corresponding Y's. So the Y's are 5, 2, 1, 2, 2. So it's 5, 2, 1, 2, 5. Did I say that right? 5, 2, 1, 2, 5. 5, 2, 1, 2, 5. Okay, good. And you double check before you move on. All right, then you're going to hit stat again. And you're going to go over to, one sec. edit, and then, oh, I'm sorry. I forgot what I was doing. You don't want to hit stat again. If you did, it's okay. If you hit stat again, just go to edit again. Okay, you're at your list. It doesn't matter actually where we were. What you actually want to do next, forgot brain fart for a second. You want to hit stat plot. See in blue above y equals. So you're going to hit second y equals so that you go to stat plot. And right now my plot 1, see how it says it's off? You want to actually turn it on. So with 1 highlighted, I'm going to push enter. And then right now, see how on off it's like solid black and it's flashing on the word on? You want to push enter so that off is no longer highlighted and just the word on is. Okay? Then you want to hit the second button. Oh, no, you don't. Then you just want to hit the graph button. And when you do, you should see your scatter plot. Okay? If you need to, stop, go back. Or if I'm going fast for you, if you miss something, stop and go back. I just push the graph button to get the scatter plot. Now, right now, I can see all 4 quadrants. If I only want to zoom in and just look at that one quadrant, so it kind of looks like how my board looks, what I'm going to do is I'm going to hit the word zoom right here. And then I'm going to go down to zoom stat, which is number 9. So you can either just hit 9 or you can scroll down to 9, zoom stat, and push enter. And now you're only viewing the first quadrant. Okay, and it kind of matches a little, a bigger version of what I have on my screen. Okay, or on my board. All right, so the next thing you want to do is come up with the line of fit. Okay, so what you're going to do next is you're going to hit stat, that stat button again. You're going to go over to calculate, and you're going to go down to, oh, I went too far. You're going to go down to number 4, linear regression, ax plus b. And it kind of looks like that slope-intercept form, right? mx plus b, but it's ax plus b. So after you're on 4, you're going to hit enter, and you'll scroll down to the word calculate and push enter again. And now they give you an equation. Okay, so it says y equals ax plus b, and then they tell you a is negative 0.078125, b, we're not even going to worry about r squared, just the r value. Okay, so I'm going to go ahead and write all that information on my board, and you guys can do the same on your paper. So for this data, we have y equals ax plus b, a is equal to negative 0.78125, b is equal to 3.25, and r is equal to negative 0.747017881. Okay? So it says to come up with a line of best fit. The line of best fit for this data is y is equal to, the a is your slope, and we're just going to round, we'll do 2 decimal points. So negative 0.78 x plus, and the b value is 3.25. That is your line of best fit. All right, which, think about it, your slope would be a negative slope, right? If we were to draw a line, it would be going down like this. It would be a negative slope, so it makes sense that your slope is negative. Okay, the y-intercept, they're saying the y-intercept would be about 3 1/4. So 1, 2, 3. They're saying the line will kind of go like this almost, something like that will be your line of best fit. And we can graph it on the calculator in a second. And then finally, your r, your coefficient, correlation coefficient is negative 0.074, or we'll just round to 75. It's negative because your slope is negative. But is this number close to -1 or not really? It's not really close to -1. So if it's not close to -1 or +1, that means that it is not very strong. It's a very weak negative correlation. Very weak negative correlation. You're either going to say it's very weak, very strong, and then it's either going to be positive or negative. It's negative because the number is negative, the slope is negative. Okay, I said we could graph, which I'll do real fast and then we'll be done. So if I wanted to graph this equation and see it in the scatter plot, I'd hit y equals right here, and that brings me to the screen, and I type in the equation we came up with. Negative 0.78, make sure you use the negative button, not the minus sign. Negative 0.78, x, to get a variable x, it's right here next to your alpha button. And then plus 3.25. And then hit the word graph again, and you'll see your line of best fit. And remember, we said it's very weak, which you can visually see it's very weak because the data points are not close to it. All right, guys, that is it. It's kind of a longer lesson than normal. Make sure you finish up your notes, and I will see you back here for the next lesson. Bye.